Hello, welcome back. Sorry, I'm trying to fix some stuff in my. I'm trying to share the link of this video to Discord. And second, can you open the Discord? Okay, very well. Can you open the chat? Amazing. So I went through the code, and there are some stuff that I want to fix right now. And the first thing is that I should never do a fake move. So I should never make a move inside the board when I'm considering it as a possibility. That's the first thing. The second thing is that there is this function updates attack maps. Yeah, this is a really expensive thing to like. It's a it's unnecessary to use this function to check if a king is under attack. I can just do it a much more simpler way. Yeah, there are two things that I just checked with the AI, and I noticed that I can just change, and hopefully it will be okay. So the first thing is that um, to filter through possible moves here. Um, okay, so instead of making a fake move and then update attacks, I will just comment all of this. And then here is the color. It's okay, I guess. The location. Okay, these things. Okay. Okay. So if it's not safe, and then const save. We call it save when check move is move save. I give it C and I will give it the move. Right? Actually, I can just okay, leave these things as it is. Let me first write the function. The possible moves of the attack maps. Okay, here I'm gonna write the function the I get a move, and then now I have to see if this move is safe. Do I need the king location? No. Do I need the turn? No. In C. Okay. I can do this. Okay. King location. On rl dot vector 2. It's a boolean. And what's the name is move safe. It's a board. And then this is a constant pointer to this. Okay. So what I will do return true, and then first I will do a sliding steps const sliding steps And then for the I will go check the queen. So these are knight moves. Knight, oops. And then there is where is the queen move? Here, this is the queen moves. Is moves save. Queen steps. Or yes, by steps. And then so sliding steps is for uh, enemy king moves. Steps for bishop, bishops, rooks, and queen. The problem is that so for the rooks, these ones are not okay. So I will have to change to diagonal and straight steps, I guess. Um, or I can just add a condition inside the same loop. Yeah, let's do, so this is straight steps, and then there is diagonal steps. Very good. So we have the straight ones and we have diagonal ones. And then there is pawn attacks. Pawn attacks are, it's a 2 to f32, which is they have to be okay, so they have to be um king location X king location dot X and some look Y king location dot X. This is +1 and look Y king location X -1 and look Y, and look Y is defined by if okay if board int from float of the king location of X int from float king location of Y. If this is the white king, then so if it's the white king, then it's the king location dot Y +1, else king location dot Y -1. So if it's the white king that we are considering, let me put this because I'm gonna need this again and again. This is const is white. And then I put here is white. So if it's white, then we need to consider black pieces, black pawns, and black pawns come down. Black pawns come down and attack towards down. So we are looking for pawns up the king. That's why we put it king location +1 and this one is king location -1. And yeah, we should look for them in two places, king location x -1 and king location x +1. That should sum up all the things we need to check. So first, checking if the pawn can attack if the king location can be attacked by pawns. To do that, we go for pawn attacks. MV. And then this move has patient. Okay, and if it's is white, it's the white king. And board at hint from code location 0, location 1. If at this location the board has a piece called is white's board a black pawn, return true. Oh no, okay. There's this here, and from dot. Very good. Okay. Okay. If it is not white king and board is a white pawn, true. Okay, that should be the white pawn attacks. Okay, just a second. I am not considering the move though. Wait, cool. Welcome, Lohit, Kirkar, Polisetti. Welcome to the stream. I hope you're having a um something is missing here. So I am not checking. So I guess pawn attacks are a little bit more complicated. I mean, it's very simple. I just have to look for pawn in these locations. But I have to do that considering the move that is proposed. So to do that, I have to check if the move can do anything to these pawns, basically. To these locations. So for example, I have to see what is the piece in this. Piece board from int from float move dot from dot x int from float move dot from dot y. This is target piece, and that's 2. Okay. So we have to imagine that this is now in 2.x, 2.y, and from .x and from .y is empty. So if okay, variable, I need to define a variable considered considered considered, and then I will put it and then we have this considered piece and the board at this location. Now if location 0 is equal to from move that from that x, and location 1 is equal to move that from that y. With sorry, because from is empty now, we can just say if location 0 is equal to move that to that x, and location 1 is equal to move that to that y, considered piece is just target piece. Considered, very good. Okay, so I first put the board location. I first consider the piece in the board location that I'm considering. I check if this is the location of the from of the move. Then we continue because that place is going to be none. So that has no threat as a pawn to the king. And then we check if the location is exactly as moved that 2, then considered piece becomes a target piece. And then we do these two conditions. Sorry, these are return false. Okay, that's all about the pawn attacks. Then we do then we do king, enemy king, king. We need to do a 4. Diagonal steps, and then here step, station. Okay. I consider location const location x to be king location dot x plus step 0. Const location y equals to king location dot y step 1. Okay. Now I have to always check if location 0 is less than 0 or location 0 is bigger than or equal to 8 or bigger than 7, but 1 is less than 0 or look 1 is bigger than 7, and continue. I have to do the same here. Here it would be x, x, y, okay. Now there is the king location plus the step. What we need to do, we need to check if in that location there is the enemy king. Consider these. To board int from dot location x, int from dot location y. If consider please if it's white and considered piece is the black king, return false. If it's not white and this is white king, return false again. Okay, that's dynamic king checking. Now let's check for I have to do exactly the same for um I have to do exactly the same for sliding steps 8. Okay, this is I will put underline. Okay. So here for king moves I can just do sliding steps. Now this one is for the king is done. For knight. Enemy knight. Um Check knight. Check knight moves here. Oh, actually I had it there. His moves, the knight moves. Okay, I just need to do copy of this. and to this knight moves. We get the location x and y, we check if it's inbound, we get the considered piece. If that's black knight, here white knight, then return false, and that's it, done. That's for enemy knights. Now for enemy rook and queen. Okay, so for that we have to go through sliding moves, but okay, what are the sliding moves? So first four moves of the sliding moves are the rook moves, and then their diagonal moves. So for 0, 4, that's an index, and then const step is equal to sliding steps I. Okay, now we have to do a while loop from the location of the king with these steps. So var x is equal to king location dot x, var y king location at y. We do a while loop while true x plus equal to step 0 and y plus equal to step 1. I'm gonna put them location x, location y. Okay, I will do this and these lines. Okay, so first we check if this location is inbound. If it's not, we continue. Then we consider this piece at this location, the piece at this location. Okay, now here is interesting thing. So first, if the considered piece is if the considered piece as a int from enum. Const is considered is white. So we check if the if is considered is white, which is to say that const value if the value is less than 7 and value is bigger than 0. Okay, is considered is black if value is bigger than 7. Okay, very good. Now, if it is white, and considered piece is the black rook or black queen, then return false. If it is not white and considered piece is white rook or considered piece is white queen, again return false. And here, if is white, the king is white and is considered piece white, we can just break out of this loop. We don't need to care about this direction. Similar with is white and is considered piece black. So for black pieces also, okay, so it just says that we continue this step until we either reach the board or here. If we do reach to the edges of the board, we should break. Or if we see that the considered piece is White is, this is too much. I can just do this. Okay, and this here. Okay, this old brick, because there is a piece in front of them that blocks um, the row or column. Now I have to check the diagonal moves. For that, so this part is exactly the same. The only thing different is this first part. And okay, it's not exactly the same, so actually I can just go here and say for sliding steps for all of it, and here define enemy piece if I is less than 4. It's okay. Var enemy piece, it's a piece if I is less than 4. I have to put switch in here, I guess. Right? No, it's not a switch thing. I have to see. Okay. Enemy piece is for now black bishop, black rook. Okay. Undefined if I is less than 4. Okay. If is white enemy piece would be, so basically if we are considering white king, we need to check it against the black rook, else enemy piece is black bishop. No, sorry, this is white rook. And here else if is white. Enemy piece is black bishop. Else enemy piece is white bishop. Is it right? Okay, so basically we are saying that we are going to consider the enemy piece to be one of these things, and then I do here enemy piece. Enemy piece. Very good. I can just put this also inside the function. Just because it takes so much time, so much space. I will put the function rook or bishop. We give it I, which is the U size, and is white the boolean, and it will return a piece. Here, return this, return this, return this, return this. And then here I just need to say rook or bishop. This is I, and that's it. And this is a constant. Okay. Okay, rooks, enemy rooks, bishop, and queen. Okay, so this is for rook, bishop, queen. This is for enemy knights, king, king, and of course enemy pawns. And so I think everything is okay now, no? Okay, so this is cool, except for two things. So if the move is castling, I have to... Okay, so if the move is castling and okay, canceling and what is it called, the thing? En passant, to be considered. There is one thing that I also think that we can... I forgot, probably. So I do check the location, move from, it should be empty, it's okay. And here, considered piece is target piece. I have to do this here as well, because... Oh no, okay. Give me a second. So here, first I have to check if the from location is the king location, and therefore, okay, if move that from that x is equal to king location that x, and move that from that y is equal to king location dot y. And I guess I have to say king location is move dot to. We update the king location. Okay. And then here, if, okay, castle, variable castled, white castled, third, false. This is black, black, long, long. Okay. Okay. Or so I think I can define nullable things for all the moves. So for example, if it's castled, I can put a nullable Raylib vector for the rook position, for the new rook position. So that would be, okay, let's comment these things for now. Var moved rook. It's a nullable RL dot vector 2. For nullable move. And it's null. The beginning. Moved, removed on. Removed on. That would be L dot vector 2 location. Okay. They removed pawn due to en passant. Moved rook due to castling. Okay, then I don't need all of this. I can just say here if move that 2 that x move that from that x minus move that 2 that x. If this is equal to minus 2, then that means that king has moved to the left side, and that's a queen side castling. The queen side castling. And moved rook will be equal to okay, now I have to define a move here. From will be something, and then to will be another. So from will have x to so x is 0 and y should be king location dot y. Otherwise x is 7 and y is king location. Very good. No, sorry. So it was in 0 and now it's in 3. If it's equal to 2, move to rook will be 7 to 5. Okay, so this should take care of castling, basically. And then now check the removed pawn. Okay, if oops, I remove the piece. Okay, I think I need the definition of the piece for the pawn thing. Because I need to see if it's a pawn. Okay, const piece. And this is piece move. This is from from. Okay, now we have all of these 3 variables. So now if piece is if it's if is white and white pawn, or it is not a white pawn and piece sorry, if it's a black king and the piece that I'm moving is a black pawn, then if target piece is none, if it's empty place and from that a move move that from that x is not equal to move that to that x, then removed pawn is okay. Then the en passant happened, and the removed pawn is if is white sorry here I will put const j location y. If it's white, if we are considering white pawn, if we are considering white pawn, doing en passant. So if it's white, the location should be move that to that y plus 1, else that to that y minus 1. Then here that x is equal to move that to that x and dot y equal to location, right? Okay, so now we are this way we have access to possibility of checking en passant and canceling as well. And we update the king location if the king is moving also. So this removes all the weird things that might happen. And then, so for canceling, we need to check rooks. Every time here, we have to check rooks as well. But for pawn attacks, we absolutely don't care. Okay, we care about the en passant though here. So here, we get the location and then we say that, okay, if the location is exactly now empty, if the location is 2, target piece, okay, and then here if say if there is a removed pawn to pawn location due to en passant, removed pawn location, then we have to check if the location is if location is pawn location, that's x, and locations 1 is equal to pawn location dot y. If this happens, we need to say continue. Because there has been a... So why do we do this? Because we are checking a pawn that is being removed due to en passant. We shouldn't check that pawn uh, anymore. So yeah, that should work. Now here, enemy king going en passant. Does it have any effect? I don't know. Let me see. So for enemy king, it doesn't matter if the rook being changed or the pawn being changed. They don't matter. It only matters if the king is able to attack our king. Then the move is not correct. This is only happening, actually, this cannot happen the pawn move. This can only happen if two kings are moving and the two kings can be hugging each other. So I don't need to check anything here. Okay, enemy knights. Do I need to check enemy knights after, like in here, does en passant change anything? No. So enemy knights are jumpy, and it doesn't matter what happens if I do castle or move the king or do any move. The knights will have their own check. The castle and en passant don't matter in this also, so enemy knights also remains the same. Okay, now here it matters. Why? Because if you do en passant, you might remove a pawn that is blocking enemy bishop or enemy queen or enemy rook, or you might even move your own pawn, and if during the en passant enemy pawn gets removed, and you might get checked. So here the en passant matters a lot, so for all three of them. For castling, I mean, I would say that it doesn't matter because it's just I'm not going to implement it for now, but if I see there is a bug, I will do it then. So for castling, it doesn't matter. Why? Because castling there would stop my king to be, like, when I'm checked, I cannot castle. That's law in check. The rule is that if the king is checked, I cannot do them. Which means that my rook will never stop any check if comes in front of the king when we do castling. So there is no need for this check also. It's impossible case, impossible scenario. The only thing that I need to care here is if I removed the removed pawn from the after the en passant, and how do I check this? I just need to check if the location is the location of the removed pawn. If so, the considered piece should be none. So this would be variable if removed pawn. location if if look x is equal to con location that's x, and look y is equal to con location dot y, what I need to do is consider this should be none. Okay. Consider piece is none if this happened. What did they do there? Until I continue. Here I do considered piece. Right. Okay. So I didn't consider castling. I believe that castling doesn't change any. I mean, does it? No, it doesn't. I'm gonna make this comment now. Let's see. Okay, only update the king location. I will make it back if there is any bug. So how do I call this function? So this one now checks a move, checks if the move is safe or not. Hi, Ivan Blue. New IO interface is confusing. Do you know how to take console input? Absolutely not. Are you using the 0.16 or 15? Because I mean, it doesn't matter anyway. I don't know how to take input from IO interface. 15.2, okay. But let me um, mm, so you have to give it a buffer, if I remember. You have to give it a fixed buffer. That's the only thing I remember. We can actually fix it. Is move safe? I will give the board and the move and the king location. Cool. I haven't used the um, I haven't been forced to use the IO interface yet, so I don't know anything about the changes there. I've heard that they're really cool, and I mean they look promising, but I don't know. I mean, people are excited about them. Okay, very good. So I can use this either in attack maps when I'm updating the moves one by one. So for example, immediately here I can consider if this move is possible or not, and then add it as a possible move. Or I can just add the everything as possible moves, and then I go through all the possible. Like it's the same principle. It's just that I don't change the code that I've written in each function. And then here, when I'm calling filter possible moves, what I need to do, I need to go through all the possible moves, and I have the locations, I have the piece and target piece. We don't care about these things. I already checked about all of this in the function. I don't care about the fake move, update math. Nothing is important here. So const safe is move safe. Now here I will pass in c.port. The move is the move, and the king location. Okay, const king location is okay. So c.turn. Then it's the white to move. King location is okay. C dot white king location else C dot black king location. Okay. Now here, if the move is not saved, remove it. I don't care about the revert thing. I just do this. Okay. Now all this nonsense on fake move and okay, I can remove them when I see that my code works, because I might see something is not working. So let's first see the errors, and if there is a bug, I will go ask for tips and how I can make this change. There was a YouTube video, I don't know if you're still in the chat, but there was a YouTube video explaining the IO changes in 0.15. I can try to share that video with you if you want. If I find it. Zig IO. I don't know if you're around. So Should I copy it in the chat? If you're in the chat, I'm gonna copy it in the chat. If not, I could just put it in Discord messages somewhere. Yeah, in Zig. Um, so here are some videos on I/O interface in. Okay, there is this link. And by the way, if any of you wants to join in anybody who's watching wants to join in the Discord server, the link is in the description, and everybody's welcome to join if you want to. We share some of the stuff that we know, like our channel, anything that we know, and we can discuss, ask questions. Okay. And there was another video. Let me see. No, there is no other video. Okay, there is only that one. It shows some of the stuff, but then yeah, I don't know the rest. Okay, that should be enough. Okay, let me see the error, by the way. Expected this, found this. How do I make, okay. I'm gonna ask the question from AI how to, yeah, I'm gonna just give this error. How to send a constant reference of the array. Like, so it produces some code that I didn't write. Is move safe. Okay. I want to support here without having without being able to change what is inside. Okay. Okay, that should be fixed, I guess. Yes, that's fixed. No field name. Form 157. 157. Okay, this is from cannot assign to constant. Ink location is constant, right? Where is it constant? Here it is constant. Okay, I'm gonna change this to location var king took equal to king location. Sorry. Says that okay, type F32 does not support indexing. Oh yeah. 194. They do the same here, yes. Here's the knight. This is the last. Okay. This expected type U size. Found this one. Sliding steps. Sliding steps. I. Oh, this is not I. This is step. And then 0. Okay. Have the board. Okay, black cannot move. Okay, there is some bugs to fix. Or is it because white can make 2 moves now? No, in the beginning of the game, white makes 2 moves. Why is that possible? I don't know. So I probably changed something in the game. day in the morning or something, or yesterday evening. Updating attack maps, filter possible moves, update possible moves. Okay. Why could it be possible that I make 2 moves? How could it be possible? Because I changed the turn here. Is it possible to have 2 turn changes? Because I only changed the turn here. I don't understand. It's okay for now. I'm going to have some rest. I will ask some question from AI. And yeah, that's it. Thank you all for watching. I hope you're doing fine wherever you are. Don't forget to follow the channel and like the video if you have not already done that. It would help us a lot. I will come back probably in a few hours, so I'm gonna have to go eat and have some rest and ask some questions. So probably in 3 or 4 hours I might come back, maybe even sooner, depends on my mood. Generally I cannot really give a exact timing on that, but I will put a post on Discord whenever I go live. So like 5 minutes before going live, I will put something in the announcement channel in our Discord server, which you can join in description. The link is there. So have fun. Let me update the GitHub page and have a happy time. See ya.